Hello children, welcome back. Let's do Playing with Numbers exercise 3.2. Exercise 3.2 is on page number 53. Question 1. What is the sum of any two odd numbers, any two even numbers? So when we add up two odd numbers, what do we get? Let's take an example. Now let's take two odd numbers 3 and 5. 3 plus 5 is 8. So as you can see, when you take two odd numbers, the answer that you get is an even number. Let's write that down. So the sum of any two odd numbers is an even number. Now let's try to find the sum of two even numbers. It says two even numbers. So let's take two even numbers, 2 and 4. 2 plus 4 is 6. So here what do you observe? You see that 2 and 4 are two even numbers and the sum is also an even number. So let's write that down. The sum of any two even numbers is an even number. Question 2. State whether the following statements are true or false. First one, the sum of three odd numbers is even. Now let's check that with an example. Three odd numbers will take 1 plus 3 plus 5. So 1 plus 3 plus 5. 1 plus 3 is 4. 4 plus 5 is 9. And as you can see, 9 is an odd number. So this statement, the sum of three odd numbers is even, is false. Question B. The sum of two odd numbers and one even number is even. So let's take an example again. Two odd numbers. Let's take 3 plus 5. These are two odd numbers. Let's take one even number, 2. Let's add it up. 3 plus 5 is 8. 8 plus 2 is 10. So this statement that says the sum of two odd numbers like this and one even number is even, this statement is true. C. The product of three odd numbers is odd. Product means multiplication. So let's multiply 1 into 3 into 5. These are three odd numbers. Let's multiply. 1 3s are 3, 3 5s are 15. So what does the statement say? The statement says the product of three odd numbers is odd. So when we multiply three odd numbers, we got an odd number. So this statement is also true. Question D. If an even number is divided by 2, the quotient is always odd. Okay, let's try that with an example. Let's take an even number 8 and divide it by 2. Divided by 2. What is the quotient? 8 divided by 2 is 4. 2 4s are 8, isn't it? And the quotient is an even number. Whereas here, what does it say? It's always odd, which is false. It can be even also, isn't it? So this statement is false. Question 5. All prime numbers are odd. Okay, now let's write down the first few prime numbers. 2, 3, 5, 7 and so on. Now all prime numbers are odd, the statement says, but look at the first prime number. First prime number is 2, which is an even number. So this statement which says all prime numbers are odd is false. Prime numbers do not have any factors. Is that true? Now let's take prime number 2. What are the factors of prime number 2? 1 into 2 is 2. So what are the factors? 1 and 2. So 2 has two factors. Whereas what does the statement say? Prime numbers do not have any factors. That's false because all prime numbers have two factors, 1 and itself. So this statement is false. Question G. Sum of two prime numbers is always even. Okay, let's try that also. Let's take two prime numbers, 2 and 3. Sum means add it up. Now 2 plus 3 is 5. Whereas what does this statement say? Sum of two prime numbers is always even. Here it's not even, it's an odd number. So this statement is false. Question H. 2 is the only even prime number. Now prime numbers, the first few are 2, 3, 5, 7 and so on. And as this statement says, 2 is the only even prime number. All the other prime numbers are odd numbers. So this statement is true. Question I. All even numbers are composite numbers. Now let's take some of the even numbers and see. Even numbers are 2, 4, 6, 8 and so on. These are all even numbers, and here it says all even numbers are composite, which is wrong because 2 is not a composite number. It is a prime number. So it's an even number which is prime. So this statement is false. Question J. The product of two even numbers is always even. Is that true? Take any two even numbers. 2 into 4. 2 fours are 8. Let's take two other even numbers. Now we'll take 6 and 8. 6 eights are 48. So this statement is true. What does it say? The product of two even numbers is always even. This statement is true. Question 3. The numbers 13 and 31 are prime numbers. Both these numbers have the same digits 1 and 3. Can you see that? 13 has 1 and 3, 31 has 1 and 3. Now find such pairs of prime numbers up to 100. So we are going to look out for prime numbers like this, like 13 and 31, which have the same digits. So let's begin. Pairs of prime numbers with the same digits up to 100. Now first thing what we'll do is we'll write down all the prime numbers less than 100. Okay, so these are all the prime numbers less than 100. Now we are going to look out for numbers like these, two prime numbers like these. Let's begin. Now we can't use any of these one-digit numbers. We must start with two-digit numbers. Now we have 11. Okay, so we'll leave that out. Now 13 and 31 are already used. It's given in the question. So let's mark that off. So 13 and 31 are already used. Now let's go to the next one. 17 is a prime number. Can we reverse the digits and say 71? Is 71 a prime number? Let's look and see. Yes, 71 is a prime number. So we can use 17 and 71. Let's write that down. That's the first pair, 17 and 71. Just like 13 and 31, we have 17 and 71. Both are prime numbers having the same digits. So we have finished with 17. We'll strike it off, 17 and 71 also. Now let's go to the next one, 19. Next one should be 91. Do we have 91? No, we don't have. Then 23, then we should have 32. We don't have 32. 29, reverse the digits, 92. No, we don't have. Now let's go to 37, and the reverse one should be 73. Yes, we have 73. So let's write that down, 37 and 73. This is the next pair of prime numbers which have the same digits. Both have 3 and 7. So let's strike it off. Okay. Now let's go to the next one. 41, if you reverse it, it becomes 14. We don't have 14. 43, if you reverse, you get 34. We don't have it. 47, 74. No. 53, 35. No. 59, 95. No. 61, 16. No. 67, 76. No. Then we'll go to 79. 79, 97. Yes. 79 and 97. That's another pair. So let's write it down. 79 and 97. So let's strike it off. So we finished with 79 and 97. Then let's go on to the next one. 83, 38. No. 89, 98. No. So we have three pairs of prime numbers, just like 13 and 31, which have the same digits. So what are they? 17 and 71, 37 and 73, 79 and 97, because we've been asked to find pairs of prime numbers up to 100. So up to 100, we have only this many. So we have three pairs of prime numbers. Question 4. Write down separately the prime and the composite numbers less than 20. Okay, so let's write that down. So first we have prime numbers less than 20. Let's start writing 2, 3, 5, 7, 11, 13, 17 and 19. These are all the prime numbers less than 20. Now, composite numbers less than 20 will be all numbers that are in between. Numbers that are not prime will all be composite. So we have 2, 3, so we write down 4. 4. Then 5 is a prime number, we write 6. 7 is a prime number, so 8, 9, 10, 11 is a prime number, 12, 13 is prime, so 14, 15, 16, 17 is prime number, so 18. That's it. Okay, less than 20 is we come up to 18. So these are all the composite numbers less than 20. So we've written the prime numbers less than 20, composite numbers less than 20. What about the number 1 that's missing? Remember, 1 is a unique number. It's neither prime nor composite. Next one, what is the greatest prime number between 1 and 10? So here we've written all the prime numbers, isn't it? Now between 1 and 10, which is the greatest prime number? 7. As you can see, 7 is the greatest prime number. So the greatest prime number between 1 and 10 is 7. Question 6. Express the following as the sum of two odd prime numbers. So now if we have 44, I have to get two odd prime numbers that will add up. That means the sum will be 44. So it's always helpful for us to keep the prime numbers from 1 to 100 ready so that we can check with this. Okay, so you have to learn prime numbers between 1 and 100 and then it's easier for us to check. Now the first number is 44. Okay, let's take 44 here. 44. Now A plus B should be 44. Okay, and A and B should be two odd prime numbers. So let's take A to be 3. 3 is an odd number, isn't it? 3 plus which number will give us 44? To find that, what we should do is we should minus 44 and 3. So let's minus 44 and 3. 44 minus 3, what do we get? 4 minus 3 is 1 and 4 here 41. Now we've got 41. We need to check to see if 41 is a prime number. So let's check and see. Yes, 41 is a prime number. So we can say 3 plus 41. We can use these two is equal to 44. So let's write that down. 3 plus 41 is equal to 44. So what have we got? We have got two prime numbers and both are odd and they add up to give us 44. The next number is 36. So again, we need to get two odd prime numbers which will add up to give us 36. So let's look at the prime numbers here. Let's again try with 3. So let's start with 3. 3, remember A plus B should give us 36. So instead of A, I'm writing 3 and we're going to find B. Both should add up to 36. That means I have to subtract these two numbers. So 36 minus 3. 6 minus 3 is 3 and 3 here 33. Let's see if 33 is a prime number. So here we have 31 and 37. So 33 is not a prime number. So we cannot say 3 plus 33 is 36. We cannot use them because 33 is not a prime number. So now instead of 3, let's go on to the next prime number 5. Let's try with 5. So A plus B, that is two odd prime numbers, should give us 36. We're going to start with A being 5. So let's say A is 5. 5 plus what will give us 36. Again, we have to subtract these two, then only we'll know. So 36 minus 5. 6 minus 5 is 1 and 3, we have 31. Is 31 a prime number? Let's look and see. Yes, 31 is a prime number. So we can say 5 plus 31, which we just found out. 5 plus 31 is equal to 36. So let's write that here. 5 plus 31 is equal to 36. So here both 5 and 31 are two odd prime numbers. Let's go to the next one, 24. This time A plus B must give us 24. So let's start again with 3. Let's try with 3. Now if I have 3 here as A, then 3 plus what will give me 24? Subtract these two to find out. 24 minus 3. 4 minus 3 is 1 and 2. I have 21. And let's see if 21 is a prime number. 21 is not a prime number. So I cannot say 3 plus 21 because 21 is not a prime number. So let's leave 3 and go to 5. So we're going to take A as 5. 5 plus B will give us 24. So let's minus 24 minus A to find B. 24 minus 5. So this is 1. 14 minus 5 is 9. 1. 19. That means 5 plus 19 is 24. But is 19 a prime number? Let's check and see. Yes, 19 is a prime number. So instead of B, I can say 19. 5 plus 19 equals 24. So let's write that down. 5 plus 19 equals 24. So what have we got here? We've got 5 and 19 and both are two odd prime numbers. The next one is 18. That means A plus B is going to be 18. So let's take 3. 3 plus what will give us 18? We know 3 plus 15 will give us 18. But is 15 a prime number? As you can see, 15 is not a prime number. So I cannot use 3 and 15. So let me try using 5. Okay, so let's try 5 plus what will give us 18? Again, you can subtract these two and find out. If you subtract 18 minus 5, you'll get 13. So is 13 a prime number? So let's see. Yes, 13 is a prime number. So we can say 5 plus 13 is equal to 18. So we've got 5 plus 13 equals 18. So here 5 and 13 are two odd prime numbers. So we've got our answers here. Question 7. Give 3 pairs of prime numbers whose difference is 2. That means you take a pair of prime numbers, you subtract the 2, your answer should be 2. Okay, so we have to get 3 pairs like that. Now, prime numbers whose difference is 2 has a special name. What is it? 2 prime numbers whose difference is 2 are called twin primes. So such numbers are called twin primes. So we're going to find that out. Again, let's have our table of prime numbers between 2 and 97. So we are going to find out 3 pairs of prime numbers whose difference is 2. So you can look at the prime numbers here and decide. Okay, when you minus, the answer should be 2. Now 2 and 3. Let's see. 3 minus 2 is 1. I cannot take that. Now what about 3 and 5? 5 minus 3 is 2. So we can take 3 and 5. Let me work that out for you. 5 minus 3 is 2. That means 5 and 3 are called twin primes. So that is the first pair. 3 and 5 is the first pair. Now let's try another one. Let's go on to say 5 and 7. 7 minus 5. Let's try that. 7 minus 5 is 2. Okay, so these two also are called twin primes. So that is our second pair. 5 and 7. These are also twin pairs. Now, let me go on to the next one. 7 and 11. Let's try 7 and 11. 7 and 11, that means 11 minus 7. 11 minus 7 is 4. They are not twin primes. So now let's go on to 11 and 13. Okay, let's try that. 13 minus 11 is 2. So these are also twin primes. 13 and 11, let's write it down. 11 and 13 are also twin primes. Now there are some more twin primes here. 17 and 19. 19 minus 17 is 2. So these two are twin primes. 29 and 31. 31 minus 29 is 2. They are also twin primes. 41 and 43. When you minus, you get 2. So they are also twin primes. So that way you have a few more twin primes. So we have been asked to write only 3 pairs. So we have 3 pairs here. Next question. Which of the following numbers is prime? So we have 23, 51, 37 and 26. Now one way is, if you have your prime numbers table by heart, you can easily say which of these numbers is a prime number. Okay. Another way is to find the factors of these numbers. So if I take 23, what are the factors of 23? That means, what are the numbers that will multiply to give me 23? 1 into 23, isn't it? Only these two numbers will give me 23. So numbers which have only 2 factors, that is 1 and itself, are called prime numbers. That means A23 is a prime number. Let's take the next one, 51. What are the numbers that give us 51? 1 into 51 is 51. Then 3 into 17 is also 51. So as you can see, 51 has more than two factors, 1, 3, 17, 51. They're all factors of 51. So 51 is not a prime number. Remember, a prime number must have only two factors. So let's go to the next one, 37. Now 37, the factors are 1 into 37. There are only two factors, so 37 is a prime number. Now 26, remember, even numbers are composite numbers. Only 2. 2 is the only even prime number. So it's easy. You don't even have to work out. 26 is an even number. So it is not a prime number. Now, what are the prime numbers that we have here? 23 and 37. We can check our table also. Yes, 23 and 37 are prime numbers. Do we have 51 and 26? Let's see. We don't have 26. We don't have 51. So this table is helpful, but you can also work it out like this and see. So let's write down the prime numbers. We have 23, which is A, and C, which is 37. Question 9. Write 7 consecutive composite numbers less than 100 so that there is no prime number between them. Okay, what do they mean? We have to write 7 numbers. They should all be composite numbers and they should be consecutive numbers. That means numbers that come one after the other. Now suppose I say 1, 2, 3, 4, 5. These are all called consecutive numbers because they come one after the other. So here we have to write 7 numbers like that, but they should all be composite numbers. And they're saying they should be less than 100 and there should be no prime number between them. So be very careful when you read your question. Follow all the conditions given. So according to this, how many numbers should we get? We should get 7 numbers. They should all be composite. They should be less than 100. And the 7 numbers, there should be no prime number in between. So first, let's write down all prime numbers from 1 to 100. Okay, so we have all these prime numbers from 1 to 100, between 1 and 100. And all those that are marked in red, as you can see, are prime numbers. Okay, those that are marked in red are prime numbers. All the others in blue are composite numbers. Now we should get 7 consecutive common numbers. So one after the other. Let's see if there are 7 numbers. So here we have only 1, 1, 1, 2, 3, 1, 1, 2, 3. We need to get 7 consecutive. Continuously we should get 7. 1, 1, 2, 3, and 1, 2, 3, 4, 5. I'm looking at only the composite numbers which are blue in color. 1. No, we need 7 numbers that come one after the other. 1, 2, 3, 4, 5. No, we need 2 more. 1, 2, 3. No. 1. Then we have 1, 2, 3. No. Here we have 1, 2, 3, 4, 5. No, we need 7. Then we have 1, 2, 3, 4, 5. No. 1 more. All the blues are composite numbers. 1, 2, 3, 4, 5. No. 1, 2, 3. No. 1. No. 1, 2, 3, 4, 5. Again, I'm reminding you, we are looking for 7 consecutive composite numbers and all composite numbers are in blue here. 1, 2, 3. No, we want 7. 1, 2, 3, 4, 5. No. 1, 2, 3, 4, 5, 6, 7. So we have got our 7 consecutive common numbers less than 100 and there is no prime number in between them. Can you see this? This last row we have from 90 to 96. So let's write that down. 7 consecutive composite numbers are 90, 91, 92, 93, 94, 95 and 96. So these are all composite numbers and they are one after the other. We have 7 and they are less than 100 and there is no prime number between them. So we have fulfilled all the conditions here. Question 10. Express each of the following numbers as the sum of three odd primes. That means I need to take three odd prime numbers, add it up, and my answer should be these numbers given here. So I have to look out for three odd prime numbers. So let's write down all prime numbers between 1 and 100. So here we have all prime numbers between 1 and 100, and we are going to use three of these to find if they will add up to these numbers here. That means if I take A plus B plus C, A plus B plus C are three odd prime numbers. Okay, if I take that, I should get 21. This is the first one. So let's begin by taking, say, odd prime numbers. So I cannot take 2, I'll start with 3 and 5. So let's take 3 and 5 and see. So 3 plus 5, and I need one more number, C. So that we have to find after adding up and subtracting. So 3 plus 5 is 8. 8 plus the third number, C, will give me 21. Now to find C, I say 21 minus 8. So let's minus and see. 21 minus 8, let's see how much it is. So here we borrow 11 minus 8 is 3, and here I have 13. So 21 minus 8 is 13. Now we have to check if 13 is a prime number. So let's see if 13 is a prime number. Yes, 13 is a prime number. That means C can be 13. So what will I have here? 3, that is A, plus 5, that is B, plus 13, that is C, is giving me 21. So I've got three odd prime numbers. Let's write it down. 3 plus 5 plus 13. These are the three odd prime numbers, the sum of which is equal to 21. Now, in the same way, let's work out for the others. So A plus B plus C is equal to 31 this time, the second one. Okay, so let's try the same numbers. 3 plus 5. So 3 plus 5 plus C is equal to 31. That means 3 plus 5 is 8. 8 plus one more number, C, should give me 31. So to find that, let's subtract 31 minus 8. Let's minus 31 minus 8. So here 2, 11, 11 minus 8 is 3 and 2. So I have 23. Can 23 be my third number? Let's check if 23 is a prime number. So let's check and see. Yes, 23 is a prime number. So my third number can be 23. So I have 3 plus 5 plus 23. So all three are odd prime numbers. So let's write that down. 3 plus 5 plus 23 will give us 31. Let's take the next number, 53. So A plus B plus C, three odd prime numbers, should give us 53. Now initially we took 3 plus 5, isn't it? Now since this is a bigger number, let's take slightly bigger numbers to get this. Let's try 7 and 11. We'll try it and see. So 7 plus 11. So let's write that. So here we have 7 plus 11 plus C will give us 53. 7 plus 11 is 18. 18 plus the third number will give us 53. So let's subtract 53 minus 18 to find the third number. 53 minus 18. This is 4. 13 minus 8 is 5. 4 minus 1 is 3. Can the third number be 35? If it is a prime number, it can be. So let's check and see if 35 is a prime number. Let's check and see here. Now here we have 31 and 37. We don't have 35. So 35 cannot be the third number. So let's try a different combination. We'll try 11 plus 13. So let's take 11 and 13 this time. Two numbers would be 11 and 13. We must find the third number. So let's do that. 11 plus 13 plus the third number will give us 53. So 11 plus 13 is 24. 24 plus C will give us 53. So to find C, we have to subtract these two numbers. So 53 minus 24. Let's subtract and see. So this is 4 and here we have 13. 13 minus 4 is 9. 4 minus 2 is 2. So now we have 29. Can 29 be the third number? It can be the third number if it is a prime number. So So let's check and see. You have 23 and 29. Yes, 29 is a prime number, so that can be a third number. So we have 11 plus 13 plus 29. Let's write that down. 11 plus 13 plus 29 will give us 53. So now A plus B plus C should give us the fourth one, D, which is 61. So again, let's take 11 and 13. We'll try with that, and we need to get one more number. So let's start working with that. 11 plus 13 plus C should give us 61. 11 plus 13 is 24. 24 plus one more number will give us 61. To find that one more number C, we have to subtract these two. So 61 minus 24. Let's subtract and see. This will become 5 and 11. 11 minus 4 is 7. 5 minus 2 is 3. So 37. Can 37 be the third number? Let's see if this is a prime number. So here 37 is a prime number. So 37 can be the third number. So what are the three numbers? 11 plus 13 plus 37. Let's write it down. 11 plus 13 plus 37 will give us 61. Question 11. Write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. That means we need to write prime numbers in pairs, 5 pairs. They should all be less than 20. Your answer should be divisible by 5. We've got an example here. 3 plus 7 is 10. 3 and 7 are prime numbers less than 20, and the answer is divisible by 5. So let's begin. 5 pairs of prime numbers less than 20 whose sum is divisible by 5. So what we'll do is first get the prime numbers chart. Numbers between 1 and 100. So we have prime numbers between 1 and 100. We're going to try different combinations to get an answer that is divisible by 5. So let's start with 2 and 3. 2 plus 3 is 5 and 5 is divisible by 5. So that is the first pair. 2 plus 3 is equal to 5. Now let's use 2 again. 2 plus 5 is 8. No, it's not divisible by 5. 2 plus 7 is 9. Not divisible. Remember, it's divisible by 5 means it should end in 5 or 0. That is 5, 10, 15, 20, 25, numbers like that. 2 plus 11 is 13. No. 2 plus 13 is 15. Yes, we can use that. 2 plus 13 is 15 and 15 is in the tables of 5. Let's continue with 2. 2 plus 17 is 19. No. 2 plus 19 is 21. Remember, we can only use these prime numbers because the question says less than 20. So we finished with 2. Let's try with 3. 3 and 5 are 8. 3 and 7 are 10, which is already there. Then we have 3 and 11, which is 14. No. 3 and 13. 3 and 13 are 16. We can't use. 3 and 17 are 20. So we can use that. 3 plus 17 is 20. 20 is in the tables of 5. Let's continue to use 5. 5 and 19. 5 and 19, no. So we can't use. So we finish using 3 and 5. Let's go to 7. 7 and 11 is 18. No. 7 and 13 is 20. Correct. 7 and 13, we can use that. So let's write that. 7 plus 13 is 20. So we've got a pair here, 7 and 13, which adds up to give us 20, and 20 is in the tables of 5. Now let's go to 7 and 17. You get 24? No. 7 and 19. You get 26? No. So we finish with 7 also. Let's try with 11. 11 and 13 is 24. 11 and 17 is 28. 11 and 19 is 30. So we can use that. 11 and 19 is 30. So we've got a pair of prime numbers less than 20 whose sum is 30, which is divisible by 5. So we finished with 11 also. So we have got 5 pairs of prime numbers now, isn't it? 1, 2, 3, 4, 5. You can find some more if you carry on. So this is our answer to question 11. Question 12. Fill in the blanks. A. A number with only two factors is called a prime number. A prime number has only two factors, one in itself. Question B. A number with more than two factors is called a composite number. So prime number has only two factors. More than two factors is a composite number. What about 1? 1 is neither prime nor composite. So 1 is a unique number. It has only one factor. Two factors is a prime number. More than two factors is a composite number. So 1 is neither prime nor composite. Next one, the smallest prime number is. Prime numbers begin from 2, isn't it? So the smallest prime number is 2. Now, which is the smallest composite number? Now, let's write down here the first few prime numbers: 2, 3, 5, 7, 11. And these are all prime numbers. What comes in between them are the composite numbers. So here we have 2, 3, 4 is missing, 5, 6 is missing, then we have 7, 8, 9, 10. So in red what you have are the composite numbers. In this, the smallest composite number is 4. So what's our answer? Our smallest composite number is 4. Now the smallest even number. Even numbers are 2, 4, 6, 8 and so on. So the smallest even number is 2. So we've finished the fill in the blanks and we've come to the end of this exercise. So we'll continue with the remaining exercises in the next videos. Thank you, children.